Solving double inequalities with adamonlinetutoring. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. Double or compound inequalities involve two inequalities combined into one statement. They are used to represent a range of values that satisfy both inequalities simultaneously. For example, with this first question, reading from left to right, 1 is less than or equal to y, which is less than 5. This means that y is greater than or equal to 1, and at the same time y is less than 5. Where y is an integer, we need to write down all of the possible values of y. Y has to be larger than 1, but can also take 1 as a value. Therefore, the smallest possible value that y could take is 1. And since we're finding integers, whole numbers, I can include 2, 3, 4. And since y has to be less than 5 and can't actually take the value of 5, we would stop with our list at 4. On to the second question. N is an integer such that negative 8 is less than 3n, which is less than 10. We need to write down again all of the possible values of n. We need to find integers for n, but notice that the compound inequality provided does not have n in the middle, similar to how we just had y in the middle for the first question. To solve this for n, we'll need to use balancing, similar to how we do when we have equations. Since n is being multiplied by 3, we can apply the inverse and divide through by 3 to leave us with n. This will involve dividing all parts of the inequality, the left-hand side, the middle part, and the right-hand side. The left-hand side would be negative 8 over 3, which is less than n, which is less than 10 over 3. Since n needs to represent integers, which are whole numbers, it might be more beneficial to write these improper fractions as mixed numbers so that we can see the next number larger or smaller than these. 3 goes into 8 twice, with a remainder of 2 left over, so negative 2 and 2/3. And 3 goes into 10 3 times, with a remainder of 1, so 3 and 1/3. So the smallest value of n needs to be greater than negative 2 and 2/3. So the lowest value it could take is negative 2, then negative 1, 0, 1, 2, and n has to be less than 3 and 1/3, meaning the largest value it could take is 3. On to the intermediate questions with an increase in difficulty. For the first one, we need to solve the inequality. By solving, we need to manipulate this similar to how we did for the last beginner question, and our answer should be a compound inequality where we just have x written in the middle part. This involves a few more steps when balancing the inequality. So in the middle, we can see that x, firstly, has been divided by 4 before we took away 1. So applying the inverse, first, we would need to add 1 to all parts of the inequality. Negative 3 plus 1 is negative 2, which is less than or equal to x over 4 would be left in the middle, which is less than 0 plus 1, which is 1. And lastly, x is being divided by 4, so we can multiply by 4 for all parts of the inequality. Negative 2 multiplied by 4 is negative 8, leaving me with x in the middle, and then 1 multiplied by 4 is 4. This is now solved with no need to list the integers that satisfy this. On to the second question, where we do need to find the integers that satisfy the inequality, but we'll first do something similar to what we did for the question before, where we solve it, and then it will make it easier to find the integers that satisfy it. This time, the first thing we did was subtract 6 from x before dividing through by 2, so applying the inverse would first involve multiplying all parts of the inequality by 2. 0 multiplied by 2 is 0, which is less than or equal to x minus 6, which is less than 2 multiplied by 2, which is 4. Next, I can add 6 to all parts. 0 plus 6 is 6, leaving me with x in the middle, and 4 plus 6 is 10. I do need to list the integers that satisfy the inequality. X is greater than or equal to 6, so my smallest value would be 6, and then listing consecutively 7, 8, 9, and I can stop there since x is less than 10, it can't actually include 10. On to the advanced question with an increase in difficulty. y is a prime number that also satisfies the compound inequality, we need to list all of the possible values of y. We'll first solve the inequality so that we can find all values that y can take. Y was multiplied by 2 before subtracting 3, so the inverse would be to add 3 to all parts of the inequality. 7 plus 3 is 10, which would be less than 2y, which is less than or equal to 25 plus 3, which is 28. And then lastly, I can divide through by 2. 10 divided by 2 is 5, which would be less than y, and is less than or equal to 28 divided by 2, which is 14. Therefore, y has to be greater than 5 and less than or equal to 14. But since y is also a prime number, I'll go through my list of values that y could take, but only write down the ones that are also prime numbers. So since it has to be greater than 5, the smallest value that it could possibly take would be 6, but 6 is not a prime number. So looking at the next number along, 7, that is a prime number. 8, 9 and 10 are not prime numbers, but 11 is. 12 is not a prime number, but 13 is. And the greatest possible value that y could take, since it's less than or equal to 14, could be 14. But since 14 is not a prime number, I won't write this one down. So my final answer for the values that y could take is 7, 11 and 13. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.